In our galaxy, there are as many as 40 billion potentially habitable planets. A potentially habitable planet is any planet that lies in a circumstellar habitable zone around a star, where the planet experiences Earth-like temperatures and Earth-like atmospheric pressure that allows for the possibility of liquid water to appear on the surface. The circumstellar habitable zone is then divided into two subzones, the conservative habitable zone and the optimistic habitable zone. Planets within the conservative habitable zone have a good chance of containing liquid water and Earth-like temperatures, whereas for planets in the optimistic zone, it is still possibly habitable but unlikely. These potentially habitable planets are also known as Goldilocks planets due to the very precise requirements they must meet in order to be habitable. However, having water and the right temperature is not enough to sustain life. Certain things such as radiation, geochemical makeup, and orbital eccentricity could outrule a potentially habitable planet. The planet Kepler 438b lies within the habitable zone of its star, but experiences much more violent radiation, similar to that of Venus, as well as solar flares, making this planet no longer habitable. One solar system, called the TRAPPIST-1 system, actually has 6 potentially habitable planets in it, including the planet TRAPPIST-1d, which has an ESI, or Earth Similarity Index, of 0.89. Many of these potentially habitable planets that we find actually seem reasonably capable of maintaining life on them. However, the biggest problem that we face in inhabiting these planets is how far away they are. The planet Kepler 1638b is a potentially habitable planet located 2,876 light years away from Earth. The closest habitable planet is Proxima Centauri b, located just 4.22 light years away. However, its habitability is not yet confirmed. Regardless of the barriers we face to ever reaching any of these planets, their potential is limitless for things such as colonization for their natural resources, since the resources on Earth are limited and scarce, but also for the possibility of meeting other forms of intelligent life. The process of panspermia is the hypothesis that life has spread throughout the universe, and the place where the life would be most likely to survive is on these potentially habitable planets. Meeting other forms of life would not only be exciting, but would open up intergalactic trading possibilities. So while the prospect of colonizing other planets and starting a galactic empire may just be science fiction for now, it is no question that these potentially rich and potentially life-supporting planets will be looked at more and more as time goes on.